Hi, my name is Rashid Ansiri and I am a doctoral engineer in mechanical engineering and I work as a technologist teacher in the Higher Institute of Technological Studies in the city of Gafsa, the country Tunisia. And I will try in this video to technologically introduce the SMAW process as simply and as clearly as possible. Well, let's go. First of all, it is to note that there is a technological variety of welding process. In other terms, there are many types of welding process. The principal ones are the GMAW, the GTAW, the SMAW, the ERW, and the OFW. And as I said before, I will talk in this video about the SMAW. Well, SMAW, as you can guess, it is an abbreviation, and this abbreviation means Shielded Metal Arc Welding. The Shielded Metal Arc Welding, the SMAW, is the most basic and the most used type of welding in industrial applications. Now I will talk about the SMAW machine. And as you can see in this figure, there is the arc welding power source, which will be of course plugged to an electric grid using an electric input power cable. This arc welding power source will produce a high electric current up to 600 amperes with a relatively low voltage around 17 volts, 45 volts. And there are two terminals in this arc welding power source, a positive terminal and a negative terminal. And now the electrode will be connected to one terminal using an electrode holder and an electric cable, and the workpiece or any parts leading the electric current to the workpiece will be connected to the other terminal using a clamp and an electric cable. Depending on whether the electrode is connected to the positive or the negative terminal, we talk about polarity, and I will talk in depth about this welding polarity in another video. Of course, in SMAW process, the workpiece will be placed on a welding table. Well, this is a picture that shows a real SMAW machine, and you can distinguish here the arc welding power source, which is mainly in blue and white, and which is plugged to an electric grid indicated in red with this black electric cable. And there are the two terminals here and here, and the two electric cables, or one electric cable will lead the electric current to the electrode holder, which is in black and red here, and the coated electrode, which is in gray. And the other terminal and the other electric cable will lead the electric current to this sheet metal using this clamp, and this sheet metal will lead the electric current to any workpiece that will be placed on it. And this is the welding table, and you can see here the fire breaks, which will refract the heat released by the SMAW process. Well, the coated electrode, as its name implies, is composed by an electrode and a coating. The role of the electrode is simply to conduct or to lead the electric current, while for the coating there are many types and many roles, several and various roles for the coating that I will talk in depth in another video. And you can see here a small part of the coated electrode that is not covered by the coating, and the electrode holder will take the coated electrode by this part. Why? Because the coating is an insulating body. And what you see here is a picture that shows a real coated electrode. You see here the coating, and under the coating there is the electrode. And by this part that is not covered by the coating, the electrode holder will take the electrode. Now I will explain the general principle of the SMAW process. In other terms, I will explain how the SMAW process works and how we can obtain a welding using the SMAW process. So, for example, we have these two workpieces. The workpiece is, of course, the base metal, and we have an electrode or a coated electrode, which is the filler metal. This electrode must be very close to the workpiece. The distance between the tip of the electrode and the workpiece must be around 1 millimeter, 3 millimeter. So the high electric current will pass from the electrode to the workpiece through the air between the electrode and the workpiece. So there are a high electric current that grows within this air. So an electric arc will be produced, and the air will release an intense heat given its high electric resistance and given the Joule heating effect. This heat will be used to heat and merge the edges of the two workpieces. So as it is indicated in this figure, the whole area between the two dashed lines will be heated and merged, and we obtain so a weld bead that ensure the junction between the two workpieces. So this real picture indicate or show a weld bead that ensure the junction between two workpieces. Well, it's the end of this video. Thank you very much for your attention.